Hello guys, now we are going to do check your progress 29.7. The first question is we need to prove that the function f of x equals 3x plus 4 is monotonically increasing function for all values of x is a member of R. Okay, so let us consider two values x1 and x2 such that x2 is greater than x1. Okay, let this be the first equation. Now when we multiply both sides by 3, we get of 1 we get 3x2 is greater than 3x1. Okay, now if we add both sides by 4 from 2 from 2 we get 3x2 plus 4 is greater than 3x plus 1 plus 4. Okay, thus we find that f of x2 is greater than f of x1 whenever x2 is greater than x1. Hence the given function f of x is equal to 3x plus 4 is monotonic function and it is monotonically increasing. Okay, let us do the second question. Show that function f of x is equal to 7 minus 2x is monotonically decreasing for all values of x is a member of R. Consider two values of x, say x1, x2, which is a member of R, and say x2 is greater than x1. Now, this is the first. If we multiply both sides by minus 2, we get minus 2x2 is less than equal to minus 2x1, because if you multiply both sides by minus, the sign changes. Okay, now if we add 7 here, we get minus 2x2 is plus 7 is less than equal to minus x1 plus 7. So f of x2 is less than equal to f of x1. Here we can see that f of x2 is less than f of x1 and x2 is greater than x1. Since so the function is monotonically decreasing function. Okay, now let us move to part C. Prove that f of x equals ax plus b where a comma b are constants and a is greater than 0 is a strictly increasing function for all values of x. So let us move to the solution for this problem. So it is given that f of x is equal to ax plus b. Let us consider the values of x as x1 and x2 which is a member of R, and let's say x2 is greater than x1. Now when we multiply both sides by a, we get ax2 plus ax2 is greater than ax1. Now if we add both sides with b, we get ax2 plus b is greater than ax1 plus b. Clearly it shows that f of x2 is greater than f of x1. Here f of x2 is greater than f of x1 and x2 is greater than x1, so we can say that the function is monotonically increasing. Okay, let us move to part D. No, there is no part D. Let us move to second question. Show that the function f of x equals x square is a strictly increasing function for all values of x greater than 0. Okay, let us consider the value of x as x1 and x2, which is a member of R, and let us consider x2 is greater than x1. Now if I multiply both sides by x2, we get x2 square is greater than x1 x2. Okay, this is the first part. And if I multiply both sides by x1, I get x1 x2 is greater than x1 squared. From 1 and 2 we can write x2 square is greater than x1 squared. So we can say the function is strictly increasing function for all values of x greater than 0. Let us move to part B. Prove that the function f of x equals x square minus 4 is monotonically increasing for x greater than 2 and monotonically decreasing for x which is between minus 2 and 2, for x is a member of R. Let us consider two values of x, x1 and x2, which is a member of R and is greater than 2. Okay, so we can write x1 x2 is greater than x1. Clearly f of x2 square will be greater than f of x1, so we can say that the function is monotonically increasing. And for x which is between minus 2 and 2, if x2 is greater than x1, f of x1 will be greater than f of x2. So we can say that the function is monotonically decreasing in this part.